I am here to talk to you about a large-scale replication project that I did. This work is preliminary. I have a lot of thoughts on open science, good, bad, and otherwise. And so, I think, in some sense, my talk will encompass all three, the good and the bad and the ugly. I'll let you decide which parts are which, okay? This work is really preliminary, and I'm the kind of person that would love to be just share, but I've learned through experience that I think kind of the new era is you just got to be careful about sharing unless everything has gone through peer review, and even then you want to be more circumspect than ever. So this is very preliminary, so there's that. So I work on this model called the limited resource model. Most people would know it by something called ego depletion. Broadly speaking, it just talks about self-control, like how do people use self-control and why do they not use self-control very well at times. And broadly speaking, the idea is just using self-control takes something away, and then people are not as able to use self-control in a subsequent period. There we go, that's the tenets of it. It's been highly, highly influential. This is one of the first papers that kind of presented this as a theoretical argument in the year 2000, 4,100 citations. One of my own papers, just about 11 years ago, we did a little rundown of all the different experiments in this realm, lots and lots of citations for that. There was a meta-analysis that came out around, so you can see 2010, or I don't know if you can see that, but it didn't do a great job reviewing the literature, I'll be honest. It's heavily relied on published data and came up with a Cohen's D of 0.62, which was a crazy overestimate. But nevertheless, at the time, this sort of sets the stage for, well, what's to come. So then there started being lots of individual reports of people failing to replicate depletion, okay. There was another meta-analysis that came out that used, in my opinion, some very puzzling types of criteria. It came out with I think concluded that there's no effect. Then the same individual who led that meta-analysis that concluded 0.62 was the effect size, then did a registered replication report, as we've now just been reminded of. And the conclusion of this was that there's a 0 effect size. Now, I and others who are original authors in the depletion literature, I didn't participate in this in large part because it didn't seem to do anything that resembled what we in self-control would say is a good self-control paradigm. And in fact, then my co-author and I, Roy Baumeister, who's chiefly known with this theory, we wrote a rejoinder to that. And you can see our title. But you can just do all this and stand on the sidelines and bitch, and that's kind of what people do with this kind of open science debate and challenges. Original authors, when their work doesn't get replicated, this isn't true wholesale, but a lot of times there's just a lot of grumbling and just okay, they did it wrong, or I don't like what they did, and I could have told you it was never gonna work, and there's just a lot of he said, she said. And I decided that I didn't wanna do that. That's not what I wanna do. But on the other hand, the way that registered replications get done these days, let me just, back up and just say briefly, yes, I work in Carlson, but my bread and butter is psychological science. So that's why all of this is in perspectives in psychological science and psych-bull, and that's my world. And so anyway, so the registered replication reports, as mentioned, you submit a plan of action. And then the reason I will, is that right? At least in my field, what happens is the journal kind of really gets into the mix and says we wanted to follow these certain criteria. Example, they really, I don't even know if this is the case anymore, but back in mid 2016 when we started our project, this was the case where everything had to be computerized, which is why this Hager pre-registered replication report did a bunch of self-control paradigm based on the computer. Well, I don't do computerized tasks. You'll see in just a second that I've been a long-standing critic of just asking people sort of what they would do or measuring reaction times as a basis for saying you're studying behavior. I mean, it's fine, but it's just not. It's not enough. So, anyways, regardless, I wanted to do something that participated in open science and participated in replications, but I didn't want to do it the way that the journals, I think, were either encouraging or requiring folks to do it. So I did it my own way. And in doing so, we created a new replication paradigm. And then that will be kind of really the crux of what I'll talk about here today. When I say we, by the way, in any of this, I mean Brandon Schmeichel. He was on my opening slide. He's been the co-leader of this project with me. And this isn't, by the way, either something that's just, something that's been happening in the background. I mean, it is, of course, but it's also timely still today. In fact, this morning, I get like this news feed that came across my email from Psychological Science of like interesting things in the news, and this was in the news this week. Military is going to build a detector for bullshit social science studies. Leave it to the military to develop what seems like a weapon, a weaponized version, and then it couches it directly in replication science. And what do they say is like, this is the article in Vohs, like, how do you know if there's like science is right? Well, any individual study can't tell you that much. That's paragraph 1. There's positive findings all the time. You got to be a little bit careful of those. And then, actually adding to the consternation, they call it confusion, rigorous testing of like all these sort of hallmarky types of effects has shown that they're like really not robust. The willpower theory of ego depletion has come crashing down. Literally this morning as I'm building my talk, and I'm like, okay, well, this is timely. And this is why, anyways, it doesn't matter. You don't need to hear my mommy stories, but I feel like So willpower, the depletion model has been held up for a while. It was kind of the poster child for what's good in social psychology, and I think it's now been held up as what's wrong with social psychology or psychological science. Okay, so in any case, getting to the open science part of the talk. What did we do? We did a large-scale replication of the depletion effect. We really kind of took a page from multi-labs. I don't have like the time or the bandwidth to get into multi-labs, but in essence, you basically involve lots and lots of different labs all over the world. And so we took a page from them, although did it a little bit differently. Well, it's still ongoing. I mean, like the data are in, but we're writing the manuscript, and so it's been now 2.5 years. Why? Well, and this you saw already that there have been some discussion about the robustness of the phenomenon. But I want to say just clearly, like our project was not developed and cannot speak to theoretical challenges to the depletion idea, which are also out there like in spades. So this is about the empirical evidentiary basis of depletion. And at the final analysis, like I wanted to be able to say, no matter what the results were of this project, we stand behind it. And that is not generally what happens with someone's own findings in the replication project. Again, not never, but generally not what happens. Who is it in the final analysis? We had the help of 3,500 participants in 36 labs all around the world, largely in North America, largely in the US, but also outside the US, Western Europe, and Australia. And net, there were 120 people who took part in this. Just as a side note, like I think experimenters are the unsung heroes of all replication projects, because what is a replication except for the execution of the study? Since up until ours, like replication studies are taken from something that's already been published and then you just redo it. And so to me, like experimenters really need to be credited and given the respect that they are due. And so that's when I say 120, all those folks are authors on our paper. I mentioned that we developed a new replication paradigm. We're calling it paradigmatic replication. To me, like if replications are going to be so important in behavioral science, which they are, then we ought to like just let 1,000 flowers bloom. Like we need to have more than one model for this. And like to the point that was made earlier about how registered replications go, you get the buy-in from a journal ex ante. And the way that we did it, I remember talking with a colleague of mine at Northwestern who's been a part of this, and before doing this paradigm, and he was just like, wait, what? You're gonna like do this, and then where will you publish it? Like you're not gonna get a journal to sign on, because I didn't want a journal to tell me what to do. I wanted to do this in a way, as mentioned, that I could stand behind it. And I said, I'm gonna publish this where the hell I want, because this is a big enough paradigm and an interesting enough phenomenon that we'll just get it published. And in fact, that will be the case. How does the paradigmatic replication approach differ? As I mentioned, I can't think of any other models, so someone can tell me if I'm wrong, but like as far as I know, replications take a published study from the literature and then replicate it, and so execute it once again. And we didn't do that. We didn't do that for a number of reasons. One is that we wanted to get tasks that represented the construct. That's why it's called paradigmatic. And like any one individual study may have a great IV, but we don't like love the DV, or may have a great DV and we didn't love the IV. And so what we wanted to do is really take what we considered, we the experts in the field, to be the most conceptually representative and also empirically robust types of tasks. As mentioned, we were the ones who came up with the IVs and the DVs, and this is already what I just said. And we think that the paradigmatic replication, like, it's not gonna be great for everything. Like, somebody comes out with a new paper in Science or PNAS or what have you, that's not, like, there's not really a paradigm quite yet, but the depletion paradigm, I mean, it's got, I think like 1,000 studies or probably more and hundreds of papers, so a very mature construct. Here are the potential advantages. As I said, it kind of speaks to theory. It gets to, like, at a theoretical level, what's the crux of the construct? Based on existing studies, we just like make up stuff anew. That wouldn't be wise. Not tied to what some other authors did. That's an important component here, because not only did I and Brandon, I think you can speak for Brandon here, want to be able to say, like, we stand behind this. We also wanted the buy-in from people in the depletion area, because I think like a third of the field at some point has kind of run a study or published a study on depletion. Like, not really a real statistic, but I mean, lots and lots of people have been involved in this arena. And part of the he said, she said component of what goes on, at least in psychological science, is it just devolves into these camps of like people who've published on it successfully, people who haven't, and then there we are. And like, I really wanted to get the buy-in from the depletion community, so we didn't want to have it tied to one person's studies, one lab studies, because it doesn't help in some ways. As we've learned, I think, from the many labs approach, you take something that was published in 1999 and it used like famous Canadian, this is a true story, famous Canadian actors as their stimuli, and then you try to redo it, well, today, so like that's not necessarily going to work. And so by doing something like this, you free yourself from some of those constraints that kind of, you want to just give the construct the best chance possible within like a proper theoretical realm. And I just mentioned that as well. And then we ended up crowdsourcing our ideas. It wasn't just like me and a couple of my buddies. We got the help of other people who work on depletion. So we ended up having this crowdsourcing type of approach. The paradigmatic replication's already been picked up by a couple of editors. The editors of this journal highlighted this approach as a way to move forward. And then Bobby Spellman and Danny Kahneman also wrote about it in a forthcoming BBS about the open science replication reformation, as they call it. Okay, our version. So we did it like this. You can do a paradigmatic replication and you don't have to do it quite like we did, but what we did is we actually had two protocols. We figured that we'd have enough labs, and in fact we did, that we'd have a lot of power, statistical power, so we had two different protocols, each of which were deemed to be good representations of the depletion construct. And then we wanted to see, like, we expected them to not vary from one another, but you never know, there could be differences, and that could be helpful for future research. As mentioned, I studied in this, and we study self-regulation and self-control, so I wanted to make sure that it studied behavior. I've written about this. This is a paper of some 10 years ago talking about how behavioral sciences are sometimes anything but that. They ask people what they would do, and they take it as prima facie evidence that this is what people do. And if the judgment decision-making literature showed us anything, it's what people say they would do or think they would do is not what they actually do. And then, yeah, we modeled these. We did a number of methodological design choices that were modeled after how some of those original depletion studies were run, those of which Brandon and I were original authors on. And we used a lot of crowdsourcing. So for example, we crowdsourced our pre-registrations. I'll tell you in a second, we worked with an advisory team who are experts in methodological and statistical design choices and experts in open science. And so we worked with them for these predictions. Boy, I love how, like, Frank, you teed me up. Like, I feel like your quiz moment was just like so intertwined with the way that this talk is going. We pre-registered everything. I mean, we had pages and pages and pages. Like, the screens couldn't handle all the text. We had to pre-register like 4 different times in order to capture everything that we wanted to pre-register. So you can see everything in here. It's like anything that you would do in a study. We pre-registered, including exclusion criteria. We worked with E.J. Vannemakers. I don't know, or you might know him as Wagenmakers. He's a Dutch guy. He was one of our main statistical advisors, and he insisted on blinding of the DV, so we did that as well, no problem. And as mentioned, we had an advisory board, which I'll tell you about in a second. I use As Predicted. I love it. It's an easy, breezy site. It's my favorite site for pre-registrations, and it looks like this. Okay. Another way that we did this is to involve the labs quite a bit. Basically, we did an iterative process whereby people who work in the depletion area came up with what we call like a menu of different independent and dependent variable tasks. And in the depletion literature, lots of times what could be an IB can also be a DV if you just kind of flip it around a little bit. So we had a menu of options, and then all the labs who wanted to participate, like we sent out this menu of options because essentially, like, so for example, like sometimes we use, in my laboratory, drinking Kool-Aid that's laced with sounds like, ugh. It sounds like a little sketchy, but Kool-Aid that's based on vinegar. It's got vinegar in it, and that will work for me. But then, like other labs are like, oh my gosh, like to get something through with the IRB for drinking things, ingesting things, is just a big hassle. So, in the classics kind of goals, like breakdown, we wanted to know how feasible these were and how desirable they were. We frame this effectiveness as like, do you think this would be depleting for your subjects? Because what's depleting to Florida State students, where my co-author, where Baumeister used to work, and what's depleting to the students at Duke University can be quite different. So we kind of all don't want to know, like, do you even think this would be a good representation of depletion? Well, anyways, we kept it going, we iterated, we went back and forth with labs, and we ended up with these tasks where they were like paired with one another, and we said, we're gonna assign you to one of them on the basis of your choice. And so, our labs chose these. And so it happened to be 50% of them chose one of these paradigms and 50% chose the other. As you can see already, like I had a lot of involvement with the labs. And the way I break this down is that I really had like my hands in the mix on everything when it came to design choices and helping the labs to execute, especially for quality control. And then we had no contact at all with the data. And so I feel like that's another important component of this, especially if you're an author who's worked in an area and published statistically significant results, and there have been challenges, and you want to do the replication. Like, there's a lot of best practices I feel like can be followed, because you don't want to do all that work and then have it fall on deaf ears because people don't trust that what you did was proper. So in any case, this was my high touch with the labs. I Skyped with all the labs, and I Skyped with every single experimenter and all the PIs and all the PhD students and everything. I made methods videos. It's like, this is me in my house, talking with them about like all the different ways I had this thing. This took me 6 hours to do because I had to stop, I'd forget something and go back, and then it looked like that. So I showed them how I want it done. Okay, I just mentioned all of this. We got videos of the experimenters. One of our colleagues, Eddie Hartman-Jones, said something to us kind of midway through when we're preparing this, like, don't you ever kind of wonder about the experimenters? Like, there's, I think I made that point about experimenters are the unsung heroes. And so we thought, like, maybe we should video them. And so we had the experimenters run a test subject, which was just generally someone else from the lab, so that we could see, are they following protocol? Turns out sometimes, like, they didn't. Were they professional? And were they, like, sort of warm or cold? Just kind of basic stuff. We also thought this could be useful for, like, ancillary data, because we just have gobs and gobs of data, and we hope and wish that other people will go in and analyze it, and this could be helpful for other folks as well. Okay. Just some other basics. We just had some more stringent criteria for how it should be run. I mentioned this, and this is an important part of it. I hired, we called him our data wrangler. I hired a guy, he was a PhD student who trained as an undergrad with Brian Nosek, and then worked with Jay Von Babel at NYU, like really invested in the open science framework. He's now at Facebook, and he was our data wrangler. So he got all the data from all the labs. He made it into like one big file, and then passed it off to our advisory board to do the analyses. So we never saw, it had nothing to do with the data. We used an advisory board, as mentioned, because we kind of wanted to make sure that what we were doing was like appropriate and would be received well, and also like, who am I? Like, I just like run studies in the lab. Like, I don't know about Bayesian methodology, frequentist metas. I don't even know that much about open science. So I wanted to make sure that we had the backing of other folks. And again, to call back to what we didn't do, we didn't get the buy-in from a journal. And if you had the buy-in from the journal, then like you don't really need maybe something like this, but I felt like we really did, and they were great. Who were they? They were people who have nothing to do with depletion, so that they have no vested interest. But again, these are folks who are just like, you know them, they're on Twitter, they're also like the editor of PsychBull, Dolores Albarrachin handles our frequentist meta-analysis. It's like, it's just folks that we really can rely on who are experts. And essentially what they did is they just told us like, here are your trade-offs, here's what you should be thinking about. They were really, really helpful with the pre-reg because they were like, you can't just say like, we're gonna test this and we expect to find that. Then you have to say, what are you gonna conclude if you find that? What are you gonna conclude if you don't find that? And we were like, oh, really? Really? Can we just say that? No, just teasing. We were like, fine, you know what I mean? Fine. But it was good to know that, right? Because again, you don't wanna go through all this and then not have the buy-in. Anyways, briefly, we tested this depletion idea. I don't want to take up too much more time. And then we did these protocols, one of which used a page like this. Subjects would cross out the letter E. I know I'm going a little bit quickly, but I think some of this can go quickly. You cross out the letter E either under difficult or easy instructions. The difficult instructions is the depletion condition. And then we used one of my favorite paradigms to get depletion self-control as a outcome measure, is just how long do people work at challenging tasks. And we measure persistence, both in terms of the number of sheets people use to trace this. This one I think is solvable, but we gave them these unsolvable figures. We wanted to know how long they'd work at them. So the idea is there's a special way you do it. You can't pick your pencil up once. And so you have to do, like basically you end up trying a bunch of different ways in order to figure out what's the correct way. And this one goes like that. And we of course informed our subjects like we told them how to do it. We went through a practice test with them, etc. And the outcome here is persistence in terms of time and the sheets used. The second paradigm that we used, protocol, is writing about a trip. This comes from the Schmeichel lab. He uses this a lot. Write a story about a trip, and if you just write a story about a trip, that's the non-depletion condition. And people just write like, hey, I went to the rec center, by the chem building, I decided to go by myself, right? And then if you're in the depletion condition, you have to write a story about a recent trip, but you can't use the letters A and N. As a funny side note, I had like a grant, I don't think we didn't get the grant, but we had a grant application with folks here at the U who work on TBI, traumatic brain injury, and some of their patients would write a story but then just skip the A's and the N's in the words, which was like really creative, but I never really anticipated that needed to be specified. So the idea is you can't use a word that contains those letters. And that's a challenge because A and N are so frequent in the English language, and so here we see folks trying it here, studied Joyce for my course, and you see another one. The outcome measure here is this one that's it's cognitive. You basically just have to think about, like if I said, like, how many giraffes are there in North America? You'd have to think, well, there's not really giraffes native to North America. Where would they be? They'd be in zoos. How many cities do you think have zoos? How many giraffes do you think are in the average zoo? You do that ad nauseum, so there are 19 items, like such as this, and such as this. And then this CET, they have norms, and you can score it. I mean, they're like huge ranges, right? And you basically just give them points as a function of if it's, like a decently reasonable answer, something that's like not that reasonable, but not that outlandish, and the outlandish ones get no points. Okay, results really briefly, because I didn't know how much time we would have, is that we do find a significant depletion effect. It is small. The frequentist people are still getting me their results, so I can't really frame it in frequentist language. Also, I'm not that facile in that, but I will say that the effect is somewhere on the order of like 0.09, 0.10, 0.11. There are some moderators. It looks like, well, there are some moderators, but like nothing that would really knock your socks off all that much. So there is a small but significant depletion effect. Oh, here's one of the moderators. After that Hager replication report came out, somebody went in and did ancillary analyses and figured out that there was a depletion effect with people who were fatigued, and so we tested that as well, and we see the same. So there's that. We're writing it up, as mentioned. I think we'll send it to Psych Science. I'm not really sure. A number of journals have expressed interest. The people at Science said we could send it there, but they said, don't get your hopes up. I was like, that's okay, I feel you. Good to try. So anyways, to recap, we Wanted to participate in the open science movement. I'll just speak for me at this point. I wanted to, but I wanted to do it in a way that I felt firmly comfortable with. And the way that I found my path is to develop a new replication paradigm. You've heard me speak about it. The way that we executed this is to use 2 different protocols and just sort of see if there's some interesting paradigmatic variation. And we involve people from experts to our labs. I think in the final analysis, there's like 150 of us on the work side of it, from our advisory board to everybody who worked with me on the depletion leadership board to all of our labs. And as mentioned, a small effect in line with expected, in line with our predictions or the predictions that would come from the depletion model. So with that, I will close and open for questions. Thank you.
All right, let her rip with questions.
Yeah, questions, comments, concerns, compliments. Yes.
How was this funded?
Me? Nobody? I mean, like, I paid labs if they had like they would submit things like I had photocopying charges because we had everything done in paper and pencil. I have this belief that subjects take things more seriously when it's on paper and pencil. I don't know. So, but I mean, it was like a couple $100. But there's no other
Personnel to execute the experimenters?
nothing. Didn't know. I mean, the labs took care of it, or I mean, like it was all. No, I mean, like it was, yeah, there was no, it was, yeah, that's a question that I didn't think anyone would ask, nor have I even thought about. No, it was great. Like we told people, like, let us know if this is a hardship, and our labs were really great about it. I think in the end, I think I paid like maybe $2,000, to folks. And I applied for a grant to the Carlson school to help out with that. I paid for half out of my research budget, and they paid for half. And so, but it was like drip drops here and there, and it was really great. Yeah. Yeah, thank you. By the way, I like names. What's your name?
Jed.
Hi, Jed. Thank you. Thanks for that comment. Yes, what's your name?
Hi, I'm Isa.
Hi, Isa.
Thank you so much for your talk. It was really interesting. And I'm just curious, so I've heard of a group that's talking about Chris Chambers' Sons in Psychology, and I think the conceptual and kind of concept level is super important. I'm curious if you think for the super hardliner replication, you think that you need to take kind of a specific protocol approach. Do you think this kind of thing might set up the stage for people to take your 2 protocols and directly replicate further to do, or do you think this kind of it seems to encompass a lot?
I mean, like to me, I mean, to answer the question you asked directly, it would be folly to me to try to take what we did and go replicate, because you would need you need the same sample size or more. Like this is like, why would you? What do I know though? I mean, sure, people could do that. And by the way, God bless. Or like, that's great and fine. I mean, that seems like if that's the approach they want to take, that would be totally fine. It would seem to me that there are like lower fruit to go to that. Yeah. You know what I mean? But just to like Isa reminded me a little bit of just sort of like hardliners. So I gave this talk at the SPSP meeting, social psychology meeting, not a month ago, but like a year, so 13 months ago. Super nervous. People were like live tweeting the event, which was just like really unnerving, and I knew that was gonna happen, but I'm glad I didn't know about it till later. And then I opened it to Q&A, and Brandon and I were like practicing like what's the meanest thing people could say in Q&A, because that's unfortunately where we are in our field. And so then Brian Nosek is the first to the mic, and I was like, okay, I was just like stealing myself, and he said, this is the best thing you've ever done. This is the best. I think this is the way forward, and never seen anything else like it, and this is how we should do it, and congrats. And he sat down, and I was like, oh my God. I basically like crumpled on stage a little bit, and then there were no other questions, and I was like, going, gone. I'm done. And so like that helped. So I mean, we're doing a lot of this for the court of public opinion, of course, because of course we're scientists, but we're scientists that have our own thoughts, opinions, biases, and beliefs, and so to know that this hit the right note, that's all that we were trying to do. Like I said, the results are going to be what they are. It's the process that I just wanted to be like, here's a process that I hope is credible and but yet that I can also stand by, so anyways, a longer answer to a shorter question, but yeah, thanks, Isa. Yeah, in the back, I can't see you. What's your name?
Alicia.
Hi, Alicia.
Hi, thank you. Again, just echoing And I really like your emphasis on the procedural data, how you did the procedure, reporting the experimenters, the para data, I think is like metadata, but
Yeah.
procedural data, which is great. I think that's missing from a lot of studies. I'm wondering, are you planning on sharing the experimenter videos?
Oh my God, everything.
That's awesome.
I mean, except for the back channel correspondence of just like how much this sucks, you know, that I'm sending to Brandon. I'm just teasing. How much of my life has gone into this? No, of course, everything, everything. Oh my God, yes. In fact, I keep meaning to build a website. There needs to be a website because we're gonna have like all even that stuff that I said, like here's what we sent to the labs initially, like here was the initial menu of options. All of that stuff, God, yes, all of it. We want it all out there. We want it all out there, including, like I said, anything that's data related as well, but anything materials related too.
Great. I'm sorry, I just had a follow-up question. Have you looked at whether there are experimenter contributions to the effects, like an experimenter moderator? I know the protocol seems to be the piece that's important. And
Yeah.
differentiate this from some of the other.
I mean, like we didn't really see much, to be honest, but it was kind of a, not even secondary, kind of a tertiary kind of a set of analyses. So we really only set out 3 different dimensions on which they could be rated, the experimenters could be rated. I think there's probably a lot more to be done there, but we just kind of wanted to just be like first approximation, are there wide scale differences? You know, the other thing I'll say is that I think by video and the experimenters, well, 1, it wasn't a real subject, which is good, but 2, I mean, it's hard, it probably squashed any natural variation that there may be in the running of the study, but I'm not saying that my experimenters didn't act that way all the time. I'm just saying, let me just say, we didn't find much, but it's quite possible other people would, like people are more skilled in like nonverbals or what have you. But yes, and I like that we did that too, and I was so grateful to the labs because I was like, totally voluntary, but do you mind? And they're all like, of course. So every single lab sent theirs. Yeah. At the side, yeah. Then in the back.
Pani.
Hi, Pani.
I really appreciated your approach and the respect for the construct and looking at the measurement
Yeah.
and the differences in measurement. And I wonder, moving forward, to anticipate that this kind of replication will find its way at a different piece. Let's say we have direct replications and then we have this type also.
Yeah, I mean, you have direct replications, you have conceptual replications. We hope so. So, you know, as mentioned, a couple folks are writing about it. After I gave my talk, I got some feelers. So there are people like in political psychology who wanted to do something like this with like, what are the best like ways to get liberals and conservatives to talk to one another. So I think that's super cool. So I'm not, you know, and I don't know, like, and I'm a featured speaker at an open science conference in September at Stanford. And so I hope to, I'm going to talk about this with them. So I hope to get more converts. But yeah, it's good for, like I said, really mature constructs. And good for ones where, like, I think the people who are in the mix and have published some of those original papers want to take part in the, yeah. So I hope so. Yeah. You had a question.
Two more that I'm gonna.
Sure.
Hi, Jeff.
Hi, Jeff.
So my question is, maybe I missed it. Do you pre-negotiate authorship when you have all these labs working with you?
Maybe we should have, huh? There's a lot of shoulda, woulda, couldas. No, I mean, like, so I said, like, I told all the labs, the experimenters, and all the any PhD student, master student, whatever, anybody who helped with the running of the study would be an author. But like, I imagine it'll just go like me, Brandon can decide he wants to be first or last, and then maybe some other key players like right up top, and then just straight up alphabetical after that.
So 300 authors, how many people did you say were
Like 120, yeah, probably 120, 150. Yeah. It doesn't, like, it's not, but yes, I mean, to me, it's credit where credit is due. So, yeah. So
Okay,
there's
this
that.
is our last one on this specific round.
Hi, what's your name?
Charisse.
Hi, Charisse.
So I was just curious, obviously a strength is that you were hands-off with the data and that's part of it. But I was curious if there was pushback for, and maybe I'm misinterpreting kind of the description, but how kind of top-down the procedure part was. So it seems like the training, everything came from you and your other collaborator, but was there pushback from just like 2 people kind of making a lot of the kind of top-down decisions, or was it?
Well, I think we really did. I mean, we really didn't make those decisions. Like, I worked with the labs to say, like, this is how I want it to be executed. Like at this point, you come in and you give them this sheet. I mean, it's essentially like I wrote out a script for the labs, and then I just acted out the script. So I don't know what that is, but our labs were part and parcel of the process by which those tasks were decided on, right? And so it's like the labs, and of course you have to have something standardized. Oh my God, of course. Like, you can't, I don't know if that's how much that's the case with other replications. Like, I've heard from some of my colleagues who've been involved with other replications that sometimes it's a bit like, here it is, just go. You know, for me, it's just like, this is a callback to something I said in the talk. Like, we ran it the way we would run the studies in our own lab, and there I always was like, hey, PhD student, run me through as a subject, right? Also, like, I wanted to know everybody who was running my studies in my own lab, so I wanted to know and have FaceTime with everybody who's running a study with me here. Like, to me, so I don't know that it was top down as much as it was like me trying to be involved and show the labs how much like I care about them, and I'm so grateful and thankful for all the work. When I think about all the work and all the time and all the people hours that went into this, like, it's really humbling, and it's very touching. So I think that's how, I can almost tell you with certainty that's how it came off, and that was how it was intended. Yeah, thanks. Okay, thanks everybody.
Just to start, I wanted to thank Frank for the opportunity to talk with you today. This is going to be obviously different than Kathleen's presentation. I wanted to highlight that part of what this emerges from is something that Frank is aware of, and a few other people here, including Jed, are aware of, that we have begun a 3-year initiative on the many faces of reproducibility, because one of the things that myself and some colleagues in statistics and psychology had noticed is that a lot of the discussion about reproducibility had been relatively narrow in terms of what was being done, and a lot of it was focused out of the open science initiative, which was a good thing, but also was emphasizing sort of technological solutions as opposed to thinking about inquiry. And some of what you're going to hear me talk about today was originally prompted by that and is part of our ongoing concern. So I just say that because if that's something that is of continuing interest to you, please feel free to get in touch with me. We will begin some of those initiatives this coming fall, and we're going to have groups on campus doing different discussions and things like that, as well as bringing in some speakers and doing some workshops and things like that. What I want to talk about today is something, one that you've already probably seen. Frank circulated the piece from PNAS that we had come out last year. I just want to raise those issues again very quickly, because part of this, I think, is a conversation. And then I want to, in the second part, sort of show you some new work that I've been doing with another co-author, trying to move beyond talking about sort of the role of failures and better understanding the diversity of failures in the sciences. Now, part of the reason why I wanted to talk again about something that's already published is there was a lot of Twitter blowback about this paper, which if you're a philosopher, Twitter blowback is sort of a strange thing, right? People don't really pay that much attention to what you're doing, and so somebody sort of sent me the altmetrics site, and they're like, wow, this is blowing up. I'm like, what do you mean blowing up? And so was looking, and there was a response from somebody who is a head of a foundation who funds the open science framework, who went ballistic on us on this paper, basically accusing us of somehow trying to paper over all the questionable research practices that were out there and the like. And now we had no intention of doing that, but the trigger made me think, okay, this sort of reinforces to me the importance of getting to the bottom of the diversity of ideas about reproducibility and failure, because it had so quickly sort of channeled into this, well, if we all just, sorry Frank, get our badges, we'll be okay. And I thought, no, that's not right. So let me just say a little bit about this paper. I won't go through all the details, but what we tried to argue there was that you've got this worry about reproducibility. It has sort of brought up questions. In fact, the Vohs story is a good example of that. Whenever the military is involved, you should probably be worried, right? The suggested policy changes have often revolved around statistical issues of p-hacking or experimental design, and yet what counts as reproduction or replication is quite diverse, which is starting to come out more and more from different authors. I'm not going to talk about that today. It's just something that has not been recognized as much. And what we were concerned about was that reproducibility failures, and especially when you look at the history of different sciences, they can happen in areas that don't have anything to do with statistics, and anything to do with experimental design. It seems like it's just a part of inquiry, that there are missteps and misinterpretations, and that in fact, the policy changes don't really see that. They all sort of overlook that kind of interpretation, and in particular this idea that you would need to integrate conflicting observations into a coherent theory over time. And that would be part of the process, and you would expect that to just be normal to do in the course of inquiry. And so we really wanted to sort of look at this role of failures in scientific inquiry, a positive role, as opposed to just this thing you're supposedly going to avoid by pre-registering. And so we drew attention to what we thought was, kind of a commonplace that, okay, you've got a typical scientific discovery is an observation that you make in your lab or in your group at some particular place and time. Another set of researchers might try to replicate it or do something similar to it. Maybe they see something different. And then you have to figure out, what are we going to do with those sorts of discrepancies or discordance? And we highlighted that an advantage of scientific journals was to sort of make all of this public, right? It basically brings it all out so that here's what my group found, here's what my group found, sure enough, they're not the same. And you've got that then in a format that can be scrutinized, right? It doesn't automatically lead to consensus, it doesn't automatically lead to resolution. The history of science has got all kinds of stories of people taking pot shots at each other and disagreeing about their favorite theories and the like. But what it does is it makes it public. It makes it something that's accessible and something that can be worked on. And I think that what is probably not surprising, we didn't mean it to be surprising, is that progress in the sciences is really sort of feeding on these things. It takes them, and that's kind of the raw material for moving forward. And you don't expect it to close things off, right? One of the things I talk about with my students is that you never hear scientists at the end of the day say, you know what, I solved the problem, I've got about 20 more years, I'm going to stop and I'm done. There's just no more questions, and we kind of solved it all, and I'm not curious anymore. And why is that? Well, because inquiry spawns new inquiry. And as you learn new things about the world, you want to learn new things about the world because you see things you didn't see before. And I think that it's precisely in the identification and the interrogation of those reproduction failures that you get to more reliable knowledge, but you also open up new spaces to ask questions that you couldn't ask before because you couldn't see things that were there. So what we tried to argue there was that many failures to replicate are actually failures to generalize across what researchers hoped were inconsequential changes in background assumptions, and that many of those attempts are sometimes based on incomplete explanations of the relevant mechanisms, people not necessarily fully understanding how something works yet, and that's a cycle of observation, theory, replication, reintegration, repeat, and over again. And that kind of cycle is something we should expect. It's not something that somebody should be penalized for being somewhere in the middle of. That is, being at a place where we don't quite understand something yet, and we're not quite able to explain something maybe in the depth of the way that we want to. This is something that is particularly important for the practical outcomes of research, which are increasingly emphasized, whether it's the National Science Foundation's broader impacts or other ways in which the expectation of translation is kind of heightened, I think, in a way that it wasn't even a couple decades ago. But of course, the immediacy expectation there is extremely problematic. That immediacy expectation that somehow, if you just did everything right, you would then be done, right? And again, it's a sort of strange thing to actually think that's what you would expect of the scientific process, but it is largely what has come out in the rhetoric around reproducibility. And so I'm not going to go into the examples, but what we had hoped to do in that paper was sort of show through examples from the history of mathematics, artificial intelligence, and some other areas that are very far from, say, psychological science, where some of the dust has been kicked up most, that you have the same sorts of issues of lack of reproducibility and a process of inquiry that goes through cycles of failure, reintegration, and insight. So I think there's a couple sorts of things that maybe are truisms, but worth emphasizing, especially because they have impacts on how we think about funding and policy. Scientific conclusions should never be based on single studies. And in fact, what that suggests is we should see a kind of interaction between individual studies, finding discordance, looking for theoretical syntheses, and not expecting any one of those to be a silver bullet, but rather that you need to engage in all of them on an ongoing basis. And there should be reward structure for that as well within the sciences. These sorts of failures are normal, right? And that's part of what the sciences are doing. There should not be taken as indications of fraud that you discover discordance. All right, in somebody, you think, oh, I got a different result. Well, okay, that happens. But that doesn't mean somebody botched their protocol. It doesn't mean that somebody was trying to exaggerate their effects. Of course, they could have, but why are we jumping to that as the first interpretation? I think some of the culture of worries, especially from the broader public, has pushed in that direction. We need to recognize that we want to understand better how to use failure, right? So the biggest failure is to not learn from it, right? That's real failure. Then you have done work and there's nothing to show for it. And in fact, the history of science is replete with places where different investigators learn when things go wrong in unexpected ways. Finally, just time. This doesn't happen overnight. In order for this process to occur, you need to explore the space of a discovery. You need to think through and do different kinds of experiments, different kinds of methodologies, different kinds of reflection are required. If we're expecting that to be done on a 2-year horizon or something like that, then we are sort of set up for definite failure in terms of the way the public and policymakers view scientific inquiry. Now, I think we should sort of go down this route of emphasizing the value of failure, in part because there are negative consequences for translation that we have seen in the past when people have tried to rush things too quickly into especially clinical settings, right? Thalidomide always being the most famous example, but there are a number of examples where we've had this kind of problem. And I think we need to calibrate the expectations on how quickly results can translate in order to not end up with these kinds of failures. In fact, I think it was, speaking of ripped from the headlines, I was just listening to a story yesterday about problems with medical device implants.
On NPR.
That was on NPR, and talking about these surgeries being done before they had really good data about what would happen, and now these people are having horrendous pain and other sorts of difficulties. The things can't be removed. Well, in part, we need to recognize there are consequences for not taking that kind of time to fail, learn from the failure, and generate better knowledge as a consequence. And I think the funding agencies need to recognize that. We need to sort of emphasize that the incentives that scientists respond to are in large part funding incentives, and so if the funding agencies push along certain lines, scientists will follow. And so there is, part of this argument is not made to scientists, it needs to be made to those funding the science to recognize that that's something that we should expect of the scientific process, we should reward, and we should not somehow devalue investigators who are engaged in that kind of reconciliation project. In addition to policymakers, I think we need to think about the public image of science, right? And one of the problems, and I think this goes back to the Vohs story about the military sort of coming to save the day, is there's increasingly expectation that science doesn't fail, ever, right? And so then you have this problem, which is, oh, if scientists just did the work the way they were supposed to, they wouldn't have these problems. Right? And again, this kind of rhetoric of, oh, well, if you just pre-registered and you just made everything public, then you would get results and there wouldn't be these problems, right? As if we sort of knew everything we wanted to know in advance, as opposed to recognizing that, well, we do research because we don't know. That's part of the point, right? Is to inquire and figure out new things. That sort of image needs to make it into sort of public context, educational settings, I think, much more actively. In fact, last semester I had a good reminder of this. I was teaching a biology and society class, and we were having a discussion about remembering that science is done by humans and that humans have failures and foibles of different kinds. And in one of the response paper assignments that I got afterwards, and this, what was the most important thing you learned this week? That science is done by humans. Go figure, right? Some of them may look like robots or act like robots, but that's a different problem, okay? So, sort of this public image dimension is really important as well for how people think about and interpret science. So the upshot out of this particular comment piece was failures of reproducibility are raw material for inquiry. It's not a lack of success when an experiment doesn't replicate, but it's actually an opportunity. And that failure to reproduce is only the first step in scientific inquiry. In many ways, how science responds to these failures is what determines whether it succeeds. And I think in some ways, Kathleen's project is a great example of sort of the response, right? How you respond to that, and that the response generates something really rich over and above what we had prior to that. Now, this other component I want to share with you today, and some of you may have seen this, this is something I like. Science, if you don't make mistakes, you're doing it wrong. If you don't correct those mistakes, you're doing it really wrong. If you can't accept that you're mistaken, you're not doing it at all. I wanted to think more about the diversity of failure because just as there are different kinds of reproducibility that people have started to worry about, direct replication, conceptual replication, things like that, what kinds of failure are there? And clearly, failure is not something that has been center stage. Some of you might have seen there's a nice book by Stuart Firestein from a couple years ago called Failure, where it's a little bit of a narrative format of kind of him sort of emphasizing this out of his own research. It's a great book, but it's not particularly analytical. It's more sort of autobiographical. And what we wanted to do was try and get at these different kinds of failures, in part because the intuition is that different kinds of failures probably require different kinds of responses. And so if you can't sort out different kinds of failures, then you're not going to be able to understand what's the right response to them if we're going to be able to learn from them. So could we provide, a basic taxonomy of failure that might help achieve that? So what we tried to do was think about some of the different ways in which failure manifests across the sciences. Typically, scientists mean by failure something like not observing an expected outcome. It seems like there's two basic reasons or sort of core scenarios where that would happen. One is that a prediction was made based on existing theories or models. We call that a failure of theorizing. or an outcome has been previously observed when performing a specific experimental intervention, and we call that a failure of precedent. And the important thing there is obviously you can observe an effect and not have theorized about it. And so that those are two different things, and that you might have a greater or lesser confirmed theory, and that might affect the degree to which failures to see what you expect from the theory are taken in one way or the other. Now, out of those two sort of core subtypes, failure of theorizing and failures of precedent, at least 4 can be classified as methodological failures. Defective materials, faulty experimental designs, flawed techniques, and in rare cases, I think fraud, where fraud is in some sense trying to do these intentionally, right? So if you don't do it intentionally, if you have defective materials and your cell lines are bad and you don't know it, that's not fraud, it's just defective materials. If you know they're bad and then you go on publishing because you want to make sure you get tenure, that's fraud. But there's a 5th subtype which relates back to the earlier conversation about the problem of overgeneralization, and that is when researchers have a limited understanding of a parameter space, which is much of the time, and make mistaken assumptions about that space when they're studying it. Most of the focus has been on the method, right? It's been on how can we make sure we don't have defective materials, how can we make sure we use our statistics correctly and the like, but it's not at all clear that that is necessarily the most common sorts of failures that we should pay attention to, and especially, I think, overgeneralization failures are quite common. Now, I won't go over these in detail because I think that they're relatively intuitive. You can think about what exactly you mean by defective materials, faulty techniques, flawed experimental design. There's reasons why we want to distinguish between these. So for example, we want to distinguish flawed experimental design because there's a difference between sort of using a technique correctly and sort of setting up and organizing experiments that are sort of not appropriate to test something, right? So you could actually do the experiment correctly in terms of technique, but it won't tell you what you want to know. And so we want to keep those two things apart. But one of the things that I think is important about these type of failures is that these type of failures are the most amenable to policy intervention, right? So all of the stuff, Frank can tell us more, he's drank the Kool-Aid now at the Center for Open Science, only a little bit of the Kool-Aid, but enough, right? Is you can these are the things that you end up getting badges for, right? Or these are the things that you can kind of reinforce to, okay, if you pre-register your study or those sorts of things. That's not bad. It's great to be able to do that, right? But that assumes that this is the only thing you need to pay attention to, as opposed to potentially something else in case of overgeneralization. And causes of overgeneralization are complex. I'd be interested in talking more with folks about their own sort of experience. We think of sort of the paradigm case as, you know, many of the phenomena that are studied are just complex networks of causal variables, and you're trying to figure out what's going on. You don't have a complete map of that space, and as you investigate it, there are certain things you don't know. Those things you don't know affect the outcomes of your experiments, and you're trying to figure out what that is, but you're also trying to put them together into predictive and explanatory models. And in some cases, when you repeat an experiment, you don't get the same outcome because there is something overlooked. We tag that, just for ease of remembrance, a failure of modeling, right? So it's a part of ongoing everyday work. It isn't that you somehow have not done good science. It's just that the thing you're investigating is relatively complicated and you haven't gotten to the bottom of it yet. And so the models that you work on and that you generalize from turn out to fail in certain ways. And the response to that is to continue to work on the models, right? It's not to sort of give up. The second kind that we think is potentially important to distinguish is what we call failures of presupposition. And these are cases where there's a more sort of fundamental assumption that everybody is making that might be off, right? So classic example of this in the last 20 years in biochemistry was whether or not most active proteins are folded, right? And so what we've discovered is that there are many, in fact more than 50% now, are intrinsically disordered, and they're not folded, and yet they're still active in cellular context. That was an assumption that the whole field was making. And it turns out it makes a big difference in a lot of the protocols of measurement in terms of the pH and the things that you set for measuring those proteins, whether or not you assume they're folded. Okay? That's what we have in mind for a failure of presupposition, because that went into everybody's models, right? Whatever protein they were working on. So in that case, it's a flawed assumption. It's an assumption that had empirical support behind it. Right? It is not an assumption that somehow came out of nowhere, but it turned out to be an assumption that with further work was shown to be problematic. Now, in distinguishing these, part of what we want to do then is understand how they're connected to one another. And what we think is important is that overgeneralization failures are connected to methodological failures. And so this is one of the reasons why you can't just treat the methodological failures with the particular policy interventions, because there are these sort of interactive effects. Researchers are at risk of using suboptimal experimental designs or techniques. They don't know what parameters should be controlled, and so you can't pre-register it. You can't sort of put it in writing ahead of time that way. That's part of normal science, because scientists are kind of at the edge of knowledge. That's part of what you're doing. And so you're not going to be able to know whether or not you have a defective material in some cases, because you don't necessarily know the material well enough to know whether it's defective or not, right? That's part of what you're learning about the system, to give one example. So what we think, in kind of line with our earlier sort of argument, is that identifying and tackling those overgeneralization failures is one of the ways in which science progresses, and that if we understand them and their interconnections, then we can recognize that we're not going to just get at those by installing stricter quality controls or new incentive structures. It's not just flawed science policy, it's part of the way research works. Now, failures can be addressed, and so in this respect, I come back to the Twitter blow-up and with the sort of restatement that there's not something wrong with the initiative of, say, the Center for Open Science and the kinds of activities that they encourage. Those are all good. The question is expecting them to do more work than they really can if what is involved in failure is more than just these methodological failures. And recognizing again that it's a time-consuming process to do the integration of those failures, to figure out that you have a failure of modeling, to discover after decades that you might have a failure of presupposition in a field. But that's also how Nobel Prizes get won and people rewrite textbooks. So I think that the measures we needed to deal with scientific failure therefore not only include better quality control, a reduction of publishing pressures, but also a change in how research priorities and funding structures are established. And with that, I'm going to stop and open it up, because I would like to hear more from you guys about some of these ideas. So thank you.
Okay, happily we have some time, so some questions for Alan, and we still have some time to do more general.
Please.
How conservative should science be?
That's a really good question, because in some sense the history of different scientific disciplines is pretty clear that there is a conservative tendency in most areas of science, and so the tendency to really embrace failures and learn from them is not necessarily always an easy thing for scientific communities to do. But I think that probably one of the things that we are dealing with is that the conservativeness of science in the late 20th, early 21st century is very much a function of government sponsorship, which, sort of recognizing the sort of architecture of funding really changes post-World War II. With the NSF and the structures that now we take to be sort of normal, But those sorts of things, I think, lead us to some of where we are now, because we have a conversation that involves responsibility to the governmental agencies for that funding and what that's like. And that wasn't always true in the past. But I think it has an effect on to what degree there should or shouldn't be a conservativeness. I mean, if you think about the Silicon Valley culture, right? What is it? Move fast and break things, right? I mean, clearly that's not the way most of the sciences are thinking about it. Now, I don't necessarily want to advocate that we should somehow just adopt that. There's lots of problems with the move fast, break things because people get hurt. But the point is just sort of recognizing that some of the disposition to be conservative comes out of a response to the kinds of funding agency requirements that people are beholden to. And that's part of the reason why this is the conversation not just about scientists doing science, but also society supporting science and how it supports science and why it supports it in that way. And I think so it's got to be a bigger conversation than just particular sort of areas of science and thinking about their own disciplinary sort of proclivities. Yeah, please.
Thank you for your talk. I'm wondering if I could get your thoughts. Do you think the many-lab paradigm or the distributed paradigmatic replication is the way forward? Is that the right direction science should be taking?
So I'm skeptical of there being one right way for science to go. In fact, I tend to be cautious about saying too much about science with a capital S, because when you get out into the wild, the sciences, plural, are pretty free-range type items, right? There's a lot of different things going on depending on whether you're in particle physics or ecological field work or psychological science. So I think that some of the paradigms that you just highlighted that have been articulated recently are valuable paradigms and can achieve certain things in certain contexts, but I think what needs to be recognized is it's always related to the goal. What kind of research are you doing? Certain methods are better or worse suited to achieving those goals. I think that therefore we should be very hesitant to sort of say everybody should do X or everybody should do Y. Rather, what we should have is we are doing X because it helps us achieve these goals that we have of inquiry. And that I think is a valuable part of the reproducibility conversation because it brings to the surface. So I liked Kathleen's highlighting about them asking, well, what conclusions will you draw from this, right? So that it puts an accent on making things explicit that maybe were more implicit before, and that includes not only conclusions but also methodological choices. That's great. I'm going to be a champion of something like that. What I'm going to be hesitant about is thinking there's a silver bullet, thinking that if we all went this way, we'd solve all the problems and the like. It's really, in that respect, one of the metaphors that I use is that parts of the open science movement sometimes feel like, we're saying there's an app for that. Science, I got an app for that, right? It's right, and it's like, wait a second, that's a technological sort of view about what's going on in science, and certainly parts of science are technologically infused, and we need to pay attention to that. But the process of inquiry itself is not a technology, and therefore we should be careful about treating it as such. Thank you. Yeah.
So my question is, I feel like in education there's a lot of fadism, and we're also chasing a moving target.
Mm-hmm.
Like we study something about education, but the whole educational system is like dramatically changing at a very rapid pace. So how do we even recognize that failure is occurring? Because it seems like things just change, and I don't see it in the science, but I don't necessarily see all of that change as being through inquiry. It's just fads and...
Yeah, no, that's a really good question because it raises some of the ways in which the particular area of inquiry that you're in has certain kinds of challenges. And some of those challenges you know from historical experience, so like the fad structure of seeing, well, we've seen stuff come and go before, and so we're kind of more wary of it as a consequence. But also we deal with a moving target, that the phenomena we study is not stable. We can't just go back out into the field and there it is again, and we can study this over and over again. And I think those challenges are quite genuine, and I don't know if I'm going to have necessarily any sort of immediate helps for that, but I think what I would go back to is this idea of, but if you're explicit about what you're doing, if you sort of openly acknowledge, hey folks, this is our challenge. Our challenge is our phenomena is a moving target. And in the past, that has encouraged people to sort of jump on bandwagons and chase things inappropriately. Okay, how then do we move forward and not just recapitulate those patterns in the future, knowing full well that it's still going to be challenging, but can we make that explicit? Can we do that? Now, part of what you need there is, again, a larger conversation, because it will not help if the community of researchers sort of embraces that, but the funding bodies don't, right? That's the catch-22 there, right? And so I think that's, and of course right now, certainly in our current political moment with respect to things like education, it's not like there's a lot of responsiveness to research at all. And so I think that the hardest part of the kinds of recommendations that come out of this kind of work is an awareness that science doesn't sort of just need to clean its own house, which is some of what happens in the reproducibility conversations is, oh, we just need to kind of get our house in order. No, we actually need a larger conversation about sort of the sciences in society and what are we doing. And that's hard. And it's especially hard in the political moment we're in, but it's going to be hard no matter what. And I think that it is, though, the way forward, and I think it's one of the things that I would like to see. So part of what we're trying to do with this Many Faces of Reproducibility project that we're engaged in is we're trying to do some public outreach events where we would start, at least, to bring some of this conversation out of sort of the university context and into communities, schools, and other settings where you recalibrate and figure, okay, to some degree, this is going to be a generational argument. Like, it's going to succeed if we can convince those who are currently sort of becoming adults in society that they take on a different picture than those who are already adults. And that's a multi-decade type task, but I think that's actually the way you're eventually going to really shift the ground. Because otherwise I think that some of the success internally to apply some of these measures about reproducibility in particular disciplines will then bump up against these sort of broader infrastructure dimensions that haven't changed in society more generally. And so, yeah, I mean, I think that it's just a reminder that, part of your challenge is sort of within your own area, so to speak, education, the phenomena being a moving target and the like, but then part of it is also the expectation of the funding agencies and the broader political entities about what kind of work are you doing and why is it important and what should we expect of it. And if we should expect of it, in a year or two, you will be able to tell us, should we teach to the test or not, right? Then you're in trouble. Because it's a false expectation. Yeah, Ellen.
A question from online. Could you point to a positive example, either already present or in the process of emerging, where these issues of generalization have been explored sufficiently or to some benefit?
The example of the protein biochemistry case, I think, is a good one, because what you see in a relatively short amount of time is that the community went from resistance to the idea that proteins could be have sort of an unfolded natural state, to recognizing that once that was sort of taken on board, it opened up new avenues for understanding how certain kinds of cellular processes worked that we couldn't understand before because they were not visible to us under that old presupposition about the proteins. So I think that's a nice one in recent sort of biochemistry, cellular molecular biology. I think that there are other areas where you can sort of see those kinds of payoffs taking place. That's the one that I'm most familiar with. So I work in philosophy of the life sciences, and so some of those examples are my the closest to what I'm aware of. But I don't think it's unusual. I don't think it's something that like if you were to go hunting, you would have trouble finding in different areas, whether you're looking in physical science, life science, social science, or somewhere else. Please.
I was thinking about this issue of overgeneralization, which you've identified as like a potential for growth and learning, which I think some researchers have responded to instead by being more agnostic about their theories about results. And I'm wondering what you think about like being atheoretical, how that would either hinder growth or...
So here I think we learn some lessons from history, because there have been times in the past where scientists did exactly that. They said, theory is the problem, we're going to be atheoretical, we're just going to collect data and sort of let the theory fall out, which you might imagine is probably not a good strategy. But in fact, some of those things, a classic example is behaviorism in the history of 20th century psychology, right, where you sort of say, I'm not going to make any claims about mental states, psychological constructs, we're just going to study the behavior, and we're going to do that operationally. We can then, ground it empirically. Well, clearly there's a problem with that strategy because actually under-theorization leads to problems as well. You have difficulties interpreting data and making sense of it if you do that. So there is a little bit of a natural dance going on there where you need theory, you need the empirical data, you need them to be in a kind of tango of sorts, and you can't sort of go completely theoretical or go completely empirical. There are trends in different areas where when new methods allow for especially high throughput data, you see areas tend to sort of poo-poo theory, like, don't give me theory, I got data coming in, and a good example of that in the 2000s was synthetic biology, where they were able to do a lot of sort of high throughput work, and the idea was oftentimes, well, the answer is just going to kind of fall out. We'll do pattern recognition on the data, and it'll just sort of pop out. This is what we need. And in recognition of the difficulties that posed, a number of people sort of realized subsequently that they needed to sort of frame a richer kind of theoretical skeleton around that. So I sort of see it as you sometimes are watching a pendulum move back and forth, where certain people are frustrated with, I've got too much data but I can't make sense of it, or I've got a lot of theory but I don't have a lot of data, and that where that pendulum is depends a lot on what your particular disciplinary area is. Yes, there's a sort of, you're aiming for a kind of golden mean, but that's the pendulum problem. It keeps swinging. So I don't think at the end of the day you want to somehow like stick your flag in the ground and go atheoretical.
We're winding down. I want to thank our two speakers. I'm going to give Jed the last question. That's all you did. You want to ask one in there? No? Anybody else? Ken Bartlett, you have the floor.
Yeah.
I want to thank Alan and Kathleen for your presentation. It was fascinating. Alan, I'm wondering, what does this mean for our role as faculty in advising and mentoring the next generation of scientists?
That's a really, really good question, because when talking with different scientists, I find that sort of reactions to sort of how you think about failure and the like depends a lot on the laboratory or the mentoring context you came out of. Some people really sort of were given wide space to fail and learn from it, and other people were in a little bit more of a factory setting where they were sort of set on a task and they just executed the task. I think that from the perspective of a mentor, sort of undertaking how do you communicate some of these things, it seems like there's a role for brutal honesty in the process of scientific inquiry, that we don't paper over a kind of messy quality of research, and help people sort of recognize that the goal is not to sort of be in absolute control of it. And I think to some degree this is one of the things that makes me want to calibrate sort of the open science framework recommendations, because part of what you sometimes get out of that is we'll control it all. We'll have all those things pre-registered, and nobody will be able to move, and we'll be in good shape. And I think, no, what you really want out of a good researcher who is sort of blossoming and flourishing into somebody who's going to make major contributions over the course of their career is somebody who has learned skills of metabolizing failures, who can do it because it happened and they had to learn, and they didn't have a net, or they didn't have or the net allowed them to sort of get up quickly and try again, and that sort of environment is constructed. It's something that mentors have to actively, I think, communicate, because there's a high sense of anxiety among graduate students, as well as postdocs these days, in part because of the tightness of the job market and other sorts of things, where everybody's kind of got a little bit of a pins and needles, and am I making it? Am I going to get the publication in time? And so I think mentors do need to really actively work on this, because if they don't, then the sort of general message that might get absorbed is one that will sort of have a fear of failure and sort of actively avoid it, which in the long run means they won't do as interesting or good science.
Okay, everybody, thank our two speakers.
Yeah, thank you.